which is a special kind of solar cells. Advantages are renovation and at last the conclusion. Next please. First of all, the introduction. What is Vitricity? Now we have the wired Vitricity transmission. As our dignitaries said, that there will be a time when no wire will be present to transfer electricity from one part of the world to other part of the world, or from one place to other place. On the same thing, we have researched here. The transmission of electricity without using any interconnecting medium is called wireless electricity transfer. It is based on the same communication network as we are communicating between the two different objects, such that we can communicate between the two different places via electricity transmission. We can transmit electricity from one place to other place without using any kind of interconnecting medium. That's called wire. This kind of electricity transmission is called the third generation power transmission. Next please. Now the solar power satellites. What is the solar power satellite? We have satellite in the space just to communicate for the weather forecasting and for remote sensing. The same thing we can apply here is the satellite, which will consist of the solar panels which will receive the sunlight from the sun, convert it to the microwave and send it to the earth surface, where we can use it for our domestic purposes. We know that sun is a renewable source of energy, and we can use this renewable source of energy for as an everlasting power source. Just to make it sun as a renewable, the sun is a renewable source of energy. To utilize it completely, we have used this concept. Next please. Next is the carbon nanotubic solar cells. Carbon nanotubic solar cells are special kind of solar cells that are made out of carbon nanotubes, which increase the internal efficiency of the solar cells, but it reduces the weight. Nanomaterials have the potential to enhance the performance of each layer in the cell. As per the Vitricity transmission, this solar cell is called the third generation solar cell. Next please. First of all, the methodology. Basically, Vitricity can be carried out by the three main methods, that is induction, microwave transmission and laser transmission. Method of inductance is possible only for short distances, as we have our transformers. But method of laser transmission and microwave transmission can have a boon, and they can be used for large distance communication, large distance transmission. Next please. For that, we must know the difference between the laser and the microwave. First of all, the microwave. Microwave is more developed than that of laser, and laser, it is a recently developed. Laser means light amplification by stimulation emission of radiation. It is a developed method, but the microwave is pre-existing method. Nextly, microwave gives an efficiency of at about 85%, whereas laser does not give the efficiency of at about 85%. So I think microwave is more convenient for transmission of electricity. Secondly, beams are far below the lethal level of concentration even for prolonged explosion. Even if we explode microwave for a prolonged time, the concentration of microwave does not decreases, but it remains the same. But laser, it do increases, and the range of 10% 20 year efficiency within few years. First of all, the problem which we are facing in microwave transmission is the interference of microwave with the current communication channel. And the problem which we are facing for the laser is that it causes skin burns to human beings, and we are trying to just move away those problems in the present systems. Next please. It's a ground level transmission. First of all, the proposed project. The proposed project of the ground level transmission is to transmit the electricity from one point to other point wirelessly. Suppose that we want to run a fan, we want to light a bulb. So we can just switch it on and transmit the electricity through any medium and just make the current flow. The benefit of this project is we can save much energy. Next please. It can be achieved by using different components in transmitting and receiving sides, as we can have a microwave converter for the electricity such as magnetron and an antenna to transmit the electricity, and on the other side we can have the rectenna to receive electricity and to again convert it, receive microwave and to again convert it into electricity, and then we can use that electricity for the domestic purposes. Next please. First of all, the transmitting side. We have a block diagram of transmitting side. It consists of an AC power source, as we have AC 220 volt or other kind of AC transmit that we are going to transmit. Nextly, we have a power conversion. We must convert the electricity that we are receiving into the respective power, such as microwave or laser. And then the transmitting side. We have a microwave transmitter. This transmits the microwave power signal to the far distant places. Next please. And this is the receiving side. It consists of rectenna. Rectenna is device. It is also called a rectifying antenna, which is used to rectify the microwave which we are receiving. Rectenna rectifies the microwave and it converts the microwave to the power conversion, and at last we achieve the power conversion. Secondly, we must regulate the power. The power which we are getting from a rectangle is not regulated. We must regulate the power, and then we must transmit that power into the remote devices. Next please. Rectangle. It is the shape design of the rectangle that is being in the foreign countries. Sorry, I don't know the name of the country basically, or I forgot. It is a type of rectangle, the design of rectangle, which is used to receive the microwave from the far space. And this rectangle converts the microwave into the power, and power is regulated, then it is transmitted for the other works. Microwave are received at this rectangle at about 85 efficiency, but the main problem which is we are facing in a rectangle is the size of the rectangle must be large. If the transmitter is near the earth, we must make the size of the rectangle as large as possible. And we must make it that the 95% of the beam must fall on the rectangle, then only we can get the 95% efficiency of conversion of microwave back to electricity. Next please. Solar power satellites. Solar power satellites. We have a satellite in our space. Just we want to mold it. We can mold the satellite because it remains in the face of the sun for more than 100%, more than 90%. So most of the sunlight falls on the satellite. We can use that sunlight that is falling directly on the satellite to convert it into a microwave using certain devices. For that, for the storage purposes, we can put the solar cells which are recently developed, that's called nanotubic solar cells. Secondly, as I have learned in yesterday's special paper presentations, that 45% of the total sunlight only we receive on the earth. To utilize the 100%, we must deploy such systems that receive 100% satellites over the earth's surface, 100% sunlight on the satellite. And secondly, devices like magnetron convert it to the microwave and transmit them on the earth's surface. And devices like rectangle that we have already planted on the earth's surface, that rectangle receives microwave and conversion of energy takes place, and then we can transmit it for the domestic purpose. This is a view, an estimated view of the solar power satellites where we are receiving energy from the sun, converting back that energy into the microwave, and again sending that energy to the earth's surface. Here it is being shown by a light spot, and the energy is shown by the reflected light. Next please. Advantages of earth-based solar power. First of all, as I have already discussed, that we will receive more intense sunlight on the satellite rather than on the earth. Secondly, high conversion factor. As we have high light on satellite, we have the high conversion factor. The conversion factor of the conversion of electricity into the microwave will be high. Secondly, for geostationary orbit, as we have geostationary satellites which are placed at about 36 kilometers away from the sun, will be illuminated for the 99% of the time to the sunlight. That is a boon for the man. Secondly, there is no need for costly storage devices when the sun is not in view. First of all, when the sun is not in view, then also the satellite will continue to transmit electricity because the satellite is under the influence of the sun. Next please. Transmitter and receiver topologies. As we can see here, as the transmitter reaches near to the earth, we must have the size of the rectangle or the receiver very large so that it must receive at about 95% of microwave that the transmitter is sending. Carbon nanotubic solar cells. Carbon nanotubic solar cells are a special kind of solar cells which are being developed in foreign countries and that we are using in such a system. Carbon nanotubic solar cells is made up of carbon material. A thin slice of carbon material is rolled, is termed as carbon nanotubes. They are widely used in solar cells to increase efficiency and increase conductivity. The main benefit of carbon nanotubic solar cell is that it increases the internal efficiency of the solar cell and it reduces the weight. Suppose we are by terms of weight, suppose we are installing 500 grams of solar cells in a particular place, and if we install these solar cells, we can receive a much amount of power. Next please. Third generation solar cells. Carbon nanotubic solar cells are also called as third generation of solar cells. It is being manufactured by depositing a commercial silicon wafer on efficient solar cells. Third generation solar cell is much broader group of technologies, all of which we are in developing phases. It includes the carbon nanotubes, nanostructures, semiconductors and amorphous silicon. Carbon nanotubes is the basic key device that will be installed in the solar cell which increases the internal efficiency of the solar cell. For that, produces more than 90% of the sunlight into the electricity. And then we can store it, that electricity, and then we can transmit it to the earth. Next please. First of all, effect. As I have previously discussed the effect, it have high efficiency and the cost of manufacturing these type of solar cells is very low because carbon is present in everything. We can just extract the carbon and we can just make it into the carbon nanotube and we can implant into the solar. And less in weight, and it have high carrier mobility. The mobility of carbon nanotube is much high as we compare it with the other silicon or germanium cells. Next please. First of all, advantages and renovation. What would be the advantages? First of all, as we have talked in the other day, the previous day, that the fuels on the earth is going to be exhausted within 100 or 200 years. At that time, there would be a challenge for the mankind that what fuel we must use. And we have the alternate that we must use renewable source of energy, that is our wind power or solar power. We are using wind power in a great extent, but we are not using solar power up to that extent that it is available to us. The efficiency of solar power plant and transmitting electricity, I must say solar power satellite, is more than these fossil fuels, nuclear energy or ground-based solar power. The efficiency of the solar power plant that we are deploying in the space is much above than these power project that has been installed in the earth. The cost of the project is high once the cost of the project is very high, but we will receive the electricity for hundreds of next year. Thank you. The next please. Advantages. We have an unlimited energy resource. As we know that sunlight is a renewable source of energy. So using this technology we have an unlimited energy resource. And the energy which is being transferred is anywhere in the world. There is no scarcity of energy. As we can see that in the remote area where there is no electricity, people can't receive electricity through any kind. We can use this technology and they could be receiving the electricity. Secondly, zero fuel cost. As I already told that once the investment is high for this particular project, but we can receive electricity for the next hundreds of years. So the fuel cost would be zero. We can use it at ground level to charge our mobile, to charge our laptop, and to run our trains, aeroplanes, anything, just to transmit electricity from the ground. Next, minimum long-range environmental impact. As we have, any project being developed is have a drawback. Yes, sir? That will I will say. Minimum long-range environmental impact. The environment will also be impacted by such a technology because as a new technology is developed, it do have some type of environmental effect. Now the challenge is to remove the environmental effects and to make it this process into practical, in which the whole world is being researching. Second, zero carbon dioxide emission. In the ground level application of the project, as we know that the human or anything, every vehicle or everything run by fuels, first of all we have disadvantages like the natural resource, the fuel is exhausting and the environment is being polluted by the emission of carbon dioxide. We can reduce such impact on the environment. The next is solar radiation can be more efficiently collected in space. As I have already discussed before that solar radiations can more efficiently collected in space rather than on the earth. So either of deploying a solar power plant on the earth, we can deploy that solar power plant on in the space. Next please. Sculpture of transportation system. As I have already decided, is a sculpture of future transportation system. There are bus stand and there would be a beam which are transmitting electricity to the bus and the bus is being charged on every stop. And there are cars and there are motorbikes which are being deployed by the same technology. It's public transportation recharge in interstate. Next please. Now the sculpture of room gadgets. If we implant these technologies at a very small level where there is no need for us to recharge our mobile through electricity, we have to just deploy this electricity as written there with electricity and we can charge our laptop, we can charge our mobile, we can run our TV and we can run our other gadgets easily. For that there is no need to charge our mobile, to charge our laptop or to exploit the resource. First of all, disadvantages. Now every project is being coming into the practical have some disadvantages. Some of the disadvantages which I personally feel here is written. The capital cost for the practical implementation of wireless power transmission seems to be very high. as the capital cost is very high. We know that first we have to make a solar cell, then we have to deploy it on the space, we have to receive it, and we have to again convert it. The capital cost for the installation of the project is very high once, but we will continuously receive the electricity for the next hundreds of years. Secondly, would require a network of hundreds of satellites. The hundreds of satellites must be required, or I must not say it's hundreds. I must say it is less than 100 because the radius of the Earth will be covered by the 4 to 5 satellites that will be continuously in the presence of Sun at an alternate of periods. Alternate periods they will receive the electricity from sunlight from the Sun and convert it and sending back to the Earth, so that no part of the Earth would be remain in dark. Nextly, possible health hazards. And it consists of microwave. There are possibly health hazards which are being tremendous for the mankind. So the challenge is that to remove this kind of health hazards or to develop such a system that health hazard does not occur. Next please. At last the conclusion. As I have already told that the idea is a boon for mankind. If this idea is being into practical, then the first of all the advantage is we can recycle our renewable source of energy. We can save our natural resources like environment, trees and everything which are being cut to install industries, and those industries transmit the carbon dioxide to the space which are affecting the earth. The hole in the ozone layer is the fact example of the thing. Nextly, the nanotechnology used in the system keeps the efficiency of the system higher and helpfully reducing health hazards. If we use the nanotechnology in solar cells, first of all, we are getting a high efficiency solar cell. Secondly, if we use this nanotechnology in the other transmitting and receiving devices, possibly we can reduce the health hazard. Eco-friendly system for power generation and transfer keeping the environment sustained. We will definitely move to the sustainable development if this system comes in the practical. Finally proves to be the next generation power system. As we have the topic of smart grid that is called the next generation transmitting system, I say that this project is the next generation power system. And these are the references which we have taken from the IEEE format and other things. Next please. Thank you, and if anyone has any query regarding the project, most welcome.
Presently, sir, I came from Jaipur. I am doing pursuing my engineering in Apex College Jaipur, and basically I am from Mumbai.
Okay.
Yes, sir.
You have nice collection. Just
Dr. Sumit.
just on this side. You have made actually a very good collection or compilation of the material. But just to give one simple information, suppose I put one satellite, how much power I will get from one satellite in megawatts?
Sir,
You have not given any figure. I
Yes, sir.
paper. I want to know that suppose I have already got one satellite. Because
Yes, sir.
today these satellites are already there in the space.
Yes, sir.
Satellite power requirement is made by the solar cell.
Definitely, sir.
That is that. What sort of power is required in the satellite?
Sir, I have.
Suppose we go solar power station.
Okay, sir.
Okay? In the space.
Yes, sir.
The satellite. How much power? Just one. If you are collecting the material, it is nice collection.
Yes, sir.
You want to know that
Sir, I can't give you the exact value in figures, but I have read.
None of these papers are read actually. In this paper, is there any mention? In some of these papers you read.
Yes,
This
sir.
is the collection of the paper. Right?
Yes, sir.
Nice slide you have presented. I wanted to know from a particular satellite,
Yes, sir.
right? How much power one satellite will produce? Wanted to just know because they see what happens is that we have been talking about satellite power.